October 29, 10:30. What I have noticed, if you're the first one to transplant and as the rice field begins to bloom, flowers develop seeds, panicles. The birds, lots of fowl is attracted to the seeds, and if you're the first one to have the rice fields bloom, many birds will migrate to your rice field. So I said to myself, well, they have the right to eat, and I don't want to kill them. So the option is to scare them away. So I bought this recently from Lazada. They've taken the silk off, meaning the reference. The name though is SR04M-2. This is the ultrasonic, so a sensor. So I'm going to use it to detect the birds flying across it. This is actually used for vehicle when you're moving backwards. And this is an adapt module, adapt 9S12C, and the controller is 128 kilobytes. So this is made by Technological Arts. So I'll send a link to this, and I'll send a link to the data sheets. As long as you buy this anyway, it doesn't matter. The pins designations are all the same. So it has 5, receive, RX, DX, transmit, and ground. There are 2 pins. I might want to find out where they lead to, but they certainly would lead to the controller. This is an STM from ST Microelectronics. So they manufacture or sell a microcontroller, 8-bit. This is a 16-bit, Freescale, now NXP. So this is the pins. Okay. Later on, I'm just gonna create a sort of a block diagram how I connected the header to header. So the board that I'm using for triggering the ultrasonic is from Technological Arts. They have different product offering. They have these Raspberry Pi. If you use Raspberry Pi, they have demos breakout board, and they have other product too, like 9S12s basically. The 9S12s are Freescale, now NXP. So looking at the board that I'm looking at, looking at the board that I plan to use is the 9S12C. This is what it looks like. It has a lot of features, a lot of RAM, and a lot of hardware, PWM, lots of I/O lines, CAN, SCI, SPI ports. So it's we're gonna use that, and these are the documentation of this adapt module. So you can connect to, like for example, mechanical drawings. Oh, wonder what happened. I guess it's not linked. Anyway, this is the block diagram of the inside of the MCU, or the actually of the circuit board. So and this is the SRM04, and it's from let's see here, this is just the document, but you can buy it from DigiKey. So this is this 2-pin reset and SWIM. I'm not sure exactly what that is, but TXRX ground. So reset, probably reset the entire board. And of course these are not to be used, so left unused. So I'll add the link to the description, so just look it up there. And this is the schematic. This is what it looked like, so you don't have to reverse engineer the board. They took out, it's 4 pins, but there's 2 pin not present, so it's relevant to the design. The ultrasonic is triggered by the transformer. It has to be low voltage to high to trigger the transformer, and then the microprocess the signal, return signal. So it drives a signal, it stops, and then wait for the signal to be echoed back like a bat. So that's what it is, ultrasonic with feedback. This is the schematic of the ADAPT 9S12. Although the micro is C32, you can actually interchange with C128, larger flash memory. So it's the company used to be based in Toronto. Now the company has moved to LA. Let's see, not sure exactly where in LA. I think it's on the website. In fact, the title is not revised. I think I did this schematic. I don't remember. This must be an old schematic. Anyway, the ADAPT 9S12 has features. So it has a single CAN. This is the primary I/O. A lot of port pins. So I plan to use the PTO port T. It has, I believe, timers, input-output compare, input capture, output compare, that sort of thing. It has A to D, 7 A to Ds, SPI, SCI, port A, port B for general IOs, that sort of thing. And it has port T, port P, so PWMs. I think it has, let's see, the ports are actually multi-purpose. For example, port P0 is PWM output and key. It has a key wake up, so it has an interrupt. Port T, again, it has also can be switched. Port P0, port T0, these IOs can be switched. So for this instance, I plan to use one to trigger, output compare 1. So 1, 2, 3, 4, 5, 6, 7. I could put in, I could use 7 input capture. One basically to trigger the output compare. So 7 sensors, I could detect 7 sensors. Most likely 4 or 5. Uh, Basically looking at north, south, west, east, and then of course the horizontal, no, the Z component pointing at the sky. So uh, that's how I'm gonna use it. It has a to D, so I probably will use these to detect sunlight intensity. So I know dark and daylight because I plan to use it from 5 in the morning to 6 in the evening. Uh, Really, the birds are really active early in the morning and then late in the evening, like around 6. So it uses BDM. It's a standard way of communicating to the MCU and programming it. Crystal is 16. In the case on board is 8. So this is the BDM. Actually, oh, these are jumper JB3. So select mode. So yeah, this is the circuit board I plan to use. It has a regulator, so I can jumper it for 5 or 3.3 volts. Since the sensor module is 5, so I think with this with the jumper, I believe it's 5. So this is the adapt 9S12 circuitry. So I quickly built up a schematic of my Ultras bird repeller. The H1 represent the 9S12 and these represents the ultrasonic module, and of course I'm going to drive a loudspeaker LS1. So this is going to be what the bird will hear. Now I might have multiple speaker, but that's later. So the initial concept is to build one first, this one, and then if everything works out okay, I'll order more of the sensor and then build up maybe 4 or 5 depending on the experiment. So now I'm going to generate a program for it. Now I'm gonna create the code. I use Freescale Codewarrior version 5.2, I think. Let's see here. Yeah, this is the Codewarrior Studio. Anyways, version 5.2. So create the new project. It's 9S12. I'm using this, and I'm not using none of that, but I'm using BDM. I'm not doing C, but I'm doing I am doing relocatable assembly. I tend to do that, and this would be bird repeller. Now let's see here. Just calling it bird repeller. Slash That's correct. So I'll just make a new directory. Next. I'm just gonna finish it. Not gonna take any not anything yet. I'll do it at the project. I'll just do a none. Okay, just finish. So this is what the code look like. You'll have to do a few things, manipulating it. The parameters is really important. I'm just gonna copy it from an existing project. The including things, linkers is really important. Let's see, and then the main code. Basically, what I tend to do is just get rid of the code within, and I just use an existing code. So I'm going to open a code I had in the past. It's let's see here. It's C32, and I think, is it a demo? It's a max demo. I guess I didn't create a .c12 demo. They're all the same, I guess. Okay, so max demo then. So basically, what I tend to do is, with the max demo, I just copy the innards, because I don't want to develop code all over again, since I've already created them in the past. So from here, just copy and paste. And then close this. The parameters is really important. So here, I think the parameter is actually how the memories are defined or allocated. So it also contains the vector address. So now that I got that going, let's see here. Now I just add files to it. So add files, and the sources. Actually, why is the derivative ink there? So I just copy from here to there. Now I'm curious about the derivatives. Let's see. I have to remove this one. Okay, so the derivatives. Okay, that's all it contains. So in the derivatives here, that all that contains. Now, why would it be in the source? Anyway, I'll figure that out later. So I'm just gonna close this. Okay. So I'm gonna do a debug or compile. Debug. Make. So I'm gonna make a make. See what happens. Compile. Actually compile. So compiled. It's doing something. Now doing these codes, it's been 4 years or 5 that I've been doing this. Actually 5 years, 6, 8 years doing codes. Now in theory all of this check marks should have been done, but anyway. Make should have done it. Let's do a make again. It made it. So there's no error. Let's make an error. Let's make an error in the main code to make sure that it's actually doing its job. So something silly like a no code NO. Okay, just do a make. So there's a code, line 151, which is this. So it's pointing to. So it's actually compiled. Now the I'll recompile again. Make. Actually, the compiling is so quick. I'll move the error. The thing was out of the anyway. The error generation is outside of this window, so you didn't see it. To compile this code and program the circuit board, run debug. It runs the true time simulator. That's the tool to use to program the circuit board. So the code is loaded. I can check by actually running it. I'm running the code. It should generate some code here. So here, so all the way restart. So this is what the code will do. It actually this is an old code, so it's running technological arts. So I wrote this code for technological arts, and it does a lot of things. It's actually drive an OLED display. Well, let's see Z. Ah, I guess Z doesn't work, or A, or C. That's port AD. D. It actually simply display the status of the ports. And let's see, M. So it displays real-time data of the A to D. So from here, I'm going to start building up the bird repeller. Like I said, I really don't want to start from scratch. Typically use old code and simply add to, remove, whatever. Like for example, these OLEDs will be gone. These things will be gone. So basically, toggle the sonar, display distance. So that's how I'm basically going to do this thing. So the first thing to do, of course, and when you're doing these, is to change certain messages. Let's see here. For example, this would be change. Let's see here. Just get rid of this. And it would be called bird repeller. So version 1. And of course, I'll just get rid of these toggle sonar on. And just comment these guys out. I'll use the messages later. Sometimes it's just expediency that you're doing these things, because once you develop code, it's really you tend to become lazy. And so here I would say show distance. Okay, so one file is changed. As you can see, the check mark. and compile again, debug. Yeah. Okay, now run. Oh, what happened? Restart. Let's do here clear screen. So as you can see, bird repeller. I'll just clean this up later, but now I'm gonna show the code for creating a distance, but this would be part 2.